talking about APIs for product managers. This workshop is mainly an introduction, so I'll be keeping it light. And first on the agenda, we'll be going through some background knowledge. That will be the foundation for us to build on, right? And then we'll get into what APIs are, the types, pros and cons, and then we'll be talking about how all this knowledge fits into what we do as product managers. Because I know this conversation can get or will get a little technical, we'll have a short break in between. And it will be great if it's a conversation, right? Your input matters greatly. So I'll be asking for feedback during the call so that we can all vibe, you know? Okay, so why is this workshop important, or why are the learnings here important? Well, as PMs, we mainly find ourselves playing at the intersection of business, design, technology, right? And in the eyes of the business guys or the marketing guys, we are the techie people. And meanwhile, to the software engineers, we are those people that just stuck there. We don't really know the tech side of things. And so I've seen a lot of articles and hot takes on if PMs are supposed to be technical. And to be honest, I see where both sides are coming from. You know, my belief, though, is that technical knowledge is a great tool for any PM to have in their tool belt. And so not only will they help you know what is available to you when ideating solutions to customer problems, it also opens up a whole other world of opportunity, a whole other realm of opportunities for your business, right? And as I've said, it's to help you gain credit with the engineering team. It can be difficult being a product manager when you don't really understand what the software engineers are talking about, what the engineering team is talking about. But I'm not saying you should go out on your own and start coding APIs, right? You don't need to do that. But knowing what they are talking about and being able to converse with them on some level will definitely earn you points. And that's very important as a PM because we're supposed to influence without authority. And so on a scale of, oh, it's absolutely important. In fact, you can't be a PM without knowing things about APIs and, you know, what I'm talking about. That's not something APIs product managers should know. Rather, I'd say it's really a nice in the middle. It's a really nice to have knowledge to have, or it's a really nice thing to have. So we begin with servers and clients. Does anyone want to take a stab at what servers and clients are? Does anyone want to say something? I don't want to be talking to myself, but let me just keep going now, and then, you know, I guess the conversation would start. So servers are a piece of hardware or computer programs that they are softwares that provide functionality for other programs or devices. They accept and respond to requests made over a network by other computers. And those computers that make the requests are clients. So to bring this to our everyday life, clients are things like your browser, you know, Chrome, Safari, and server is where what you want resides. So the architecture where the client and the server provide, the client or the server provides functionality for the client is called the client server model. And so just hold on to that piece of knowledge. So now we have an idea of what clients and servers are in our minds. We can imagine that since they need to communicate, since they need to send things back and forth, request and response, there needs to be a way for them to do that. There needs to be a way for them to communicate. They need things from each other, and that's where HTTP and HTTPS come in. So I'm sure we've all seen it at the beginning of websites and all of that. We'll see HTTP dots or www, right? We have HTTPS as well. And HTTP is short for Hypertext Transfer Protocol. And the S in HTTPS is secure, means Hypertext Transfer Protocol secure, right? HTTP is essentially the way data is transferred. It's a protocol. There are several other types of protocols that we won't be getting into right now, FTP, FTPS, that's file transfer protocol, right? But HTTP is the most widely used right now. And the gist of HTTP is that it's the standard communication protocol used for the transfer of computer files from server to the client. So it's the way that the server sends things back to the client and the client sends things to the server. And the difference between HTTP and HTTPS is that HTTPS carries out its communication using a secure connection. And so with HTTP, if anybody has the time, they can easily decrypt it and use whatever information you're sending through HTTP. But HTTPS is much more secure. And so if you've noticed on a lot of websites now, it's just using HTTPS right off the bat because a lot of data is being sent, credit card information, and things like that are being sent over the network. And so you don't want someone to just be able to wake up and get that information from your website, so from whatever app you're using. So HTTP has insecure connection, while HTTP has an encrypted connection. And so let's go through the journey of an HTTP request through the internet. So we have our guy there. Let's call him Ashake. So Ashake wants to go on Amazon.com to buy a microphone, right? So he puts in Amazon.com on his browser, which we know now is a client, right? So the browser is a client. And now the request is sent using HTTP, and the request is sent to the server that has all the information that Ashake needs. And so it's very important that as Ashake has requested for Amazon.com, the response cannot be a Facebook page, right? So with the URL, that's Amazon.com, we have to get the address of the server. And the way I see it in my head is that servers have two addresses. There's one for humans, and then there's one for the computers. The one for humans are the ones that we remember, Facebook.com, Amazon.com, Paystack.com, whatever website name. And then there's the IP address, which is the one that the server is actually located at. That's the one that the computers know, right? And so when we put in the website name, the DNS, which is the domain name server, converts that website name into the IP address, and the request is sent to that address to get the information. And so the response is sent back, and Ashake can buy his microphone and sing Joha for us. So at this point, do we have any questions, comments? Am I talking to myself? I'd like to hear what you're thinking.
Hi, Tobi. You lost me a bit when you mentioned DNS.
Oh, okay. So the DNS is, think of it as the server is in one place and the client is in another. And then the DNS is just close to the client. And so when we put in Facebook.com, right, that's what we know, that's what we remember. The IP address is a bunch of numbers, 1 point something points. It's just really long. And of course, we can't remember those kind of things to be able to go to Facebook. Imagine you want to go to Facebook and you have to type 1.111.9 something, right? So the server is at the IP address, but we know it as Facebook.com. And so what the DNS does, that's the domain name server, what it does is it converts the name we know to the IP address, the actual address of the server. So the request, which is the HTTP request, can go to the right place and get the right information. And so without the DNS, things can get lost. And I could request for Amazon.com and get, waptrick.com or something. So that's what the DNS does. Is that clear, or should I go in again?
Okay, can you do like a quick recap again?
Okay, of the DNS, or
yeah, okay. Like everything from the beginning, then how DNS connects.
Okay, let me just okay, so I've said servers and clients. We've spoken about how the client is just bring it to your everyday life, right? You want to, what is something you do almost every day? What's something you do almost every day?
I eat.
Okay, I eat too, and I like ordering food. So let's say I want to order food from Jumia Foods, right? And so I go to my Chrome browser and I type in jumiafood.com, right? Simple enough. That's what I need to know. But the truth is, the server that hosts Jumia Food, where all that information on Jumia or what Jumia Food itself is on a server at an address, right? At an IP address. And so when I type in jumiafood.com, the client, right, the Chrome browser, sends what I type in to the DNS. Because the truth is, the request, which is jumiafood.com, what the address that I know is not what the computer understands. The computer speaks in numbers and logic, right? Meanwhile, we speak in like words, right? And so the DNS converts that request of the address of the request. So the request is jumiafood.com. I'm trying to see the food page for the place, right? That's my request. But it doesn't know where it's going. It needs to go to the DNS first and convert the address, that's jumiafood.com, to the IP address. And so when it converts it to the IP address, that whole request, so the page I want to get, the food I want to get, whatever it is that I've sent from my client, the Chrome browser, is then sent to the server at the correct address. So if there isn't a DNS, there probably will not be a way for us to be able to speak to the server properly, because the server is at an address and we can't really have that in our heads, as I've said. And so when we send that to the DNS converts it to the IP address, and then our request is sent to the proper address. And so that's why if I ask for Jumia Food, the place, basmati rice, I'm not getting a friend request from Facebook page, right? All of that just works together to make sure that the communication between the client and the server works right, and we as users don't have any problems with working with the client and getting the information we need from the server. So have I been able to help?
Yes, thank you.
Awesome. And thank you for that. If I'm going too fast, if you don't understand something, please draw me back. I can't really go through the chats right now, but if there's something really important, maybe message the PM Africa admin, or someone should just call me back, right? Okay, so we're going to get into HTTP methods. And there are different methods of HTTP requests. I like to think of it as types of requests. So thinking back to the example of Jumia Food, I wanted to get something. I wanted to see the Jumia Food page, right? And that's a get request in my head, right? Okay, let me use a real life example. I have younger sisters, and I like to send them on errands. They say I do it so much, and in my opinion, it's one of the best things of being like an elder sister, right? So when I send them to get something for me, I don't necessarily need to give them anything. I can just say, get me a cup, and I'm expecting a response. And that's what the get request does, right? The get request just requests something. It wants to see something, right? So the get method is literally used to get information. And so let me go back to the Amazon example with Ashake. Ashake wanted to get the information about like the microphone on Amazon.com. And so that was a get request. So then we have post, put, and patch. And three of them are used for creating, modifying, and updating data or requests. And rather than trying to explain it with words, I would just go back to my metaphor, right, with my sisters, and say I ask one of them, can you please bring me juice? So that's a post request because I created the requests and that's a whole new request. Nobody has asked for that, or I've not asked for that before, right? And so maybe as she's going, I say, hold on, don't worry. Maybe get me water instead. I want to do fit farm, right? I don't want my stomach to be big. Get me water instead. So with that, I have updated the request. I have replaced the request because I initially requested for juice, right? And now I replaced it with water. And that's how a put request works. And let's say I'm so annoying. I'm just really, really annoying. And I say, wait. Okay, so can you add a slice of lemon to that cup of water? That's a patch request because I'm just modifying the initial request. So I had initially asked for water, and then now I'm asking to add lemon to that cup of water. So that's a patch request. And so just keeping all of that in mind, how the get request is used to get information, the post request is used to create information. So in a real life situation, a post request can be you're filling out a form on a website. Say you're filling out a form about how you weren't happy with how maybe someone spoke to you on Jumia Food, like the representative was rude, and you're filling out the feedback form. That's a post request, right? And say there's an opportunity to edit that and say, oh, you know what? Yeah, I'm going to change it from I had a very bad experience to I had a very good experience. That's a put request, right? You're setting all new attributes. You're changing everything about the request that you just sent. But say you just want to change it from, you just want to add something. So this person was rude to me, was what you sent before, and then you want to say she was just extra rude. You want to add she was rude, she was extra rude. That's a patch request. You're updating or you're modifying the request. So that's post, put, and patch. And then we have delete, which deletes resources, just as the name says. So are we all good on all of these methods?
Yes.
Awesome.
Okay.
Awesome.
Hi, Tobi.
What? Hi.
Yeah, so there's a message in the chat box. We'll just read this out. So just address that before you proceed.
All right, sure.
Okay, so Tosin Oladokun is asking, is it possible that two readable human addresses are mapped to one IP address? Can you hear me?
What? I didn't get that. What did you say?
Okay, so Tosin Oladokun is asking, is it possible that two readable human addresses are mapped to one IP address?
Oh, that would be very, very bad. Well, you know what? It does happen, right? So it happens in the case of what's the word? Redirecting. So if you have, I don't know if you notice with Facebook now, if you type facebook.com and fb.com, they all go to the same IP address. So that's something that happens. If it's by mistake, then that's a very, very big problem. But people do it when you have like several website names and you just want everything to go to the same place. So as I've said, like facebook.com and fb.com, they all go to the same IP address at the end of the day. So that is something that happens. What?
Sales funnel. Depends on which part of the sales funnel you're building from.
Is this person talking to me?
Please, can you mute your mic? We can't hear those talking background.
Like that. Six.
Okay, so Tobi, I think you can continue.
Okay, great. I wanted to ask if that was cleared up, if you understood what I said.
I think Tosin, I don't need to say Tosin cool. He was the one that asked that question.
Oh,
yes,
okay.
that's pretty clear. Thank you very much.
Oh, awesome, great. Okay, yeah. So gets into the main thing, right? APIs. Okay, so API means application programming interface. That's all. Maybe we should just go home since I'm kidding. Well, simply put, an API is an interface that helps software programs connect and communicate with one another. The key word is interface, right? It's a point where two systems, programs, computers, whatever, interact. That's what an interface is. Another type of interface you might be familiar with is the user interface, right? Most of these programs, most of the apps we use have their own UI. And this UI lets us, the users, me and you, provide our own inputs into the programs and tell the program exactly what we want to happen, right? And in other words, it helps us, the users, interact with whatever program we are using. And so this is like a user to machine interaction, right? And so the API, an API works similarly, except now it's not a user to machine interaction, rather it's machine to machine interaction. And so APIs are mechanisms that enable two software programs, two software components to communicate with each other using a set of defined definitions and protocols. Excuse me. So they are the intermediary, right, that allows two applications to talk to each other. They are being used everywhere for various and several situations, business cases, and so many more. And they are the unsung heroes of a lot of things that we do that just seem pretty normal to us. And that's what's great about them, right? They don't need to be at the forefront to do the work that they're supposed to do. So each time you use an app like Twitter, maybe you send a WhatsApp message or you check traffic on your phone, you're using an API, right? Okay, so at this point, I think we can tell that I like using metaphors and real life experiences to explain things. So think of an API to be like the middleman between the application you are using and the server. Not you, but the application you're using, right? You tell the app to do something for you. Then the app will use the API to communicate with the server, telling it what to do. This action telling the API what to do, or the server what to do is the request. We've spoken about that, right? And then the server will send a response to be delivered by the middleman, which is the API, to your app. So bringing it to real life, let's say you walk into a restaurant. I've seen this example used in several places, and it's such a great example. And let's say you walk into a restaurant, you wanted to go and enjoy life. And so you pick a table, wait for the waiter to get your order. In this case, the waiter is your middleman because you can't go to the chef directly and tell the chef what you can't go to the kitchen. And the chef can't also come to you because chef is very busy. Chef has other things that he's preparing, right? So you make your request to the waiter. The waiter sends this request to the kitchen and then gets a response. And in this case, your order, pasta, jollof rice, whatever it is you ordered, and brings it to your table. So looking at this image, our client, which is the web app in the browser, sends the request and waits for the response. The API receives the requests from clients and does whatever the request needs. So whether it's a post, put, patch, get, delete, request, it does whatever it is and then sends it to the database or the server, right? And the API would query the database. So let's say it's a get request for the microphone, like Ashake did. The API would do that, query the database, and then get the information that Ashake needs and send it back to the client, right? So as I've said, we use APIs for a lot of things in technology. Some of the products that from our immediate environment that uses APIs that we can talk about now, we have Google Maps, for instance, right? If you've used ride-hailing applications, Uber, Bolt, you've most likely seen Google Maps within those applications. All those delivery applications, Jumia Food, all of those applications, you can check for how far away your delivery is. You can check for the route of your trip in Bolt or Uber and things like that. right? And then we have Paystack. So Paystack has the API where they can integrate with where business owners or e-commerce websites can integrate into their websites to be able to handle payments. And with that is a whole lot of money. That's a whole lot of calls going to that API, and that's something that we just use without really thinking about. We want to buy something, and then there's the modal that just pops up, whether to transfer or by QR code or things like that. That's the Paystack API at work. And then we also have Instagram. You've seen probably on websites where there'll be a bar where they'll put our socials or something like that, and then you see their Instagram feed just running through. That's the Instagram API at work. Those people didn't write up Instagram or code Instagram into their website. They just had to use the API, just had to integrate the API into the website. And so, as I've said, APIs are everywhere, and an understanding of what is possible and what isn't possible can help us as PMs know how best to solve the problems that our customers are having, and even solve the problems before they arise. Right? So I set up a really short brain teaser because I know that it can get really heavy, and we're at the middle of this conversation or the workshop at this point. So maybe a little brain teaser to just ginger everybody, I guess. So the first one, before Mount Everest was discovered, what was the highest mountain in the world? If anybody wants to take a stab at it. Does anyone want to say something? You can chat. Kilimanjaro. Does anyone have any other answer or?
We're having messages in the chat. So we
Okay.
have Kilimanjaro, okay.
I think Himalaya, or what do you call it?
Okay, well, let's see the answer. The answer is Mount Everest. So it's just not yet discovered, it was just always the tallest or the highest. Okay, the next one, what occurs once in every minute, twice in every moment, yet never in 1,000 years?
The letter M.
The letter M. Who else wants to try?
Oh yes.
Okay. The letter M. That's absolutely correct. Okay, so let's do a quick recap so we can move on to the second half of this workshop. I hope we're all feeling energized. I hope this workshop is workshopping. So we went over servers and clients. Servers are a piece of hardware or software that provides functionality for other programs or devices. They accept and respond to requests made over the network by other computers, which are called clients, right? Browser, server, all of that. We spoke about that. Then HTTP and HTTPS is how data is transferred or requested. They are the standard communication protocol used to transfer computer files from server to client and then backwards. And then the difference between HTTP and HTTPS is that HTTPS carries out communication over a secure network, secure connection, right? And then we spoke about APIs. APIs are an interface used to help software programs connect and communicate with one another. They are everywhere. We spoke about Paystack, Google Maps, and so on. And we've seen APIs at work in our everyday lives and how they make things really, really easy for us, right? Awesome. So now we'll be going on to the next part. We'll be talking about types of APIs, pros and cons. We'll get into what makes a good API product and, what is important to keep in mind as a PM working with APIs, and how, as a non-technical person in the team, how you can harness the powers of APIs in your products. Awesome. So there are two main buckets that APIs are usually put into. We have types of API by availability and by use cases. So by availability speaks to the release policies of APIs, so how people are able to connect or able to use those APIs, right? So we have private APIs, which are exclusively used internally within companies by employees, and they are mainly used to improve solutions within an organization. So a real life example is at your bank, right? You can go to any GT bank today with your GT account number, and the teller can tell you how much you have in your account, all the transactions you've done on your account and things like that. But you can't take a GT bank account number and to a First Bank and ask for that information. That's because the GT Bank API is being used by only GT Bank, right? And that's what they're using internally. So you can't also come to a GT Bank and give them a First Bank account number and say, oh, get me my First Bank details. Please make sure you do that. That's just First Bank's API and GT Bank's API. And so we have partner APIs, and partner APIs are used for integration of software between business partners and companies. So for you to be able to get to use this API, you have to have signed an agreement, and even money will be paid, right? Partner APIs provide value addition for a business. For instance, in real life, again, Bolt uses Google Maps API, right? And it's not for free. It's definitely not for free. And there are definitely agreements that both companies would have signed to be able or for both to be able to use Google Maps. And then another example is Paystack and e-commerce websites. So you have the Paystack API handling payments, and it's not for free. And there'll definitely have been an agreement that's made for the API to be integrated into the website, whether we know it or not. And then we have public APIs. And like the name implies, these APIs are open to the public. Anybody can use it without restriction. There are many, many APIs. There are many, many free APIs. And there are also resources. I would send that as part of my slides at the end of the workshop. But there are a lot of resources to be able to see free APIs and just play around with them, know what they do. Very, very fun APIs. I don't know if anybody watches Rick and Morty, but there's a Rick and Morty API where you can like look at Rick and Morty characters, and it's just very fun. It's open, anybody can use it. You can create very fun projects around it, and they're completely free to use. A lot of them would need an authentication key rather to be able to use with them, but they're mainly free to use. Google Maps has like a free part of the API where you can just have like a needle point of a location on a website. So that's free to my knowledge, and so on. So we have weather APIs that are completely free. You can build solutions around finding the weather in different places. And so so does anyone know any free APIs they want to mention? Any examples of free APIs? None? Or is it in the chat? I can't see.
Sorry, what was the question?
Do we know any other examples of free APIs that people can just use? I can see the chat numbers increasing, but I can't really go there.
Google Map.
Yeah, Google Map has. I didn't get that.
So there are a couple of messages dropping in. Abbas Odola is saying Google Map.
Yeah, Google Map.
Says Bloomberg Market API.
Yeah, that's a very, very good one. Yes, they have like you see, it's all around us. Yes, exactly. They are free to use, and we can create very interesting solutions and products around those free APIs as well. So let's move on to APIs by use cases. So I really don't want to go too deep into APIs by use cases, but I would just gloss over it because it's a little advanced. But I think the idea of it is that these APIs are used or classified according to the system that they are designed for. So database APIs are APIs that provide connections with database systems. So it allows communications with database systems, right? And then we have OS APIs, operating system APIs. So Windows has its own APIs, Mac OS has its own APIs, and different OSs have their different APIs. And then we have remote APIs, which are concerned with communication and interaction between different machines all around the world. So a lot of APIs are remote, but not all APIs, or not all remote APIs. I don't know what the word is. All APIs are remote, but not all remote are APIs, or something like that. Then web APIs are the ones that we are most knowledgeable about. They are the ones that help the transfer of data and so on within web-based systems. So a lot of the examples I've given actually are web-based APIs. These APIs mainly deliver requests from web applications and responses from servers using HTTP. I know that this might seem like a lot, but as I've said, nobody knows everything, and it's all just patience and taking it easy, right? I also like to Google things. So, all right, let's get into the pros and cons of using APIs. At the beginning of this workshop, I spoke about how APIs are being used everywhere. I've said it several times, and it opens up a world of several possibilities in terms of feature ideation, solutions, business revenue, and it only stops where you stop dreaming, honestly, right? And that's a top pro of APIs. It's made life very, very easy for developers, for PMs, and for business people as well. Imagine if Bolt had to build something like Google Maps just so they can have that find my location and find my routes feature. Just imagine the amount of time, the resources, the back-breaking work that would have been needed, even the resources in the first place, because Google uses a lot of satellites and things like that to be able to get Google Maps to work. So imagine if Bolt in their little stage or in their early stages had to build that just so they can have the find my location feature, right? But they can just sign an agreement with Google and integrate it into their system. And with that, PMs can focus on other things, developers can work on other things, and just imagine the meetings, the calls, follow-ups that would have been needed. It's almost unimaginable. So following that train of thought, the time needed for products to be built and released to market is also just shorter, right? We don't need to reinvent the wheel every single time we want to build something. And honestly, that's amazing. But for every good thing, there will definitely be some drawbacks. The dependency issue is one that is a headache for everyone. If today Google Maps crashes, or if Paystack has a problem, just imagine how many applications, how many businesses, transactions will be lost, right? When you have a solution that heavily relies on third-party APIs, this becomes an issue that you need to be and keep abreast of. Right? And then, of course, there's the cost. So there are some APIs that bill based on API calls. In fact, if I'm not mistaken, Paystack takes like a share of, collects a fee when you use the Paystack API in your checkouts, right? And so that's something you need to think of as a PM. You need to think of the trade-offs, and you need to think of if it's worth it that your engineers should go on and build a Paystack checkout, or if you should just integrate with Paystack checkout. So those are the things and the balance that you need to strike as a product manager. And so we're gradually reaching the end of this workshop, and I've been enjoying myself. The energy has been great, and I like that you guys haven't left me to talk to myself, right? And so I'll throw this question out. What do you think makes a good API or a good API product? If anybody wants to talk, if anybody wants to send in a chat to just get that going.
I think a good API performs the function it was designed for seamlessly and then does not interfere with the core product of the company using it or hosting it.
Yes, that's honestly great. The fact that it does what it's supposed to do makes it a great API. There are several.
Okay.
I think it limits the amount of data transfer.
Hi, Tobi. Hi, Tobi. I don't know if anyone can still hear Tobi because I can't seem to
No,
hear her.
same here. Same here.
But I'm seeing a lot of comments that are coming in, so I just wanted her to join in so I could just read those out as well.
Okay, great. I'm here. Sorry, my network got cut off. I'm back.
So while you were
Yeah.
away, there were a couple of messages that came in from the on chat box.
Mhm.
So we have from Tosin, it's reliability. From Abbas, we have has a great UX. Another person said
Okay.
99.9% availability,
99.
speed,
Mhm.
having a good and sustainable team. I don't know if that was for this. Okay.
Yeah,
Then
it sounds like it is.
having a good and sustainable team. Okay. Then uptime, 99.9% availability, and then easy access.
Yeah.
Those are a couple of
Okay,
messages.
great. To be honest, do I even need to continue this workshop at this point? So you people have literally spoken about a lot of the things that it makes a good API or a good API product. So the uptime, making sure that what needs to be delivered is delivered, making sure that it does what it does or it's supposed to do rather. So imagine if the API for Amazon.com goes to fetch Instagram. Imagine the chaos it would cause, right? And then the uptime, as you guys have spoken about, also imagine if I'm trying to pay now, I'm trying to pay on a website and then it's telling me the portal is down. What would the PM of that portal or what would the PM of that company be thinking about the fact that they are losing a lot of customers by the minutes, right? And all those things are really correct. And then another thing is the API should have good documentation. You should be able, as your users should be able to understand what your product is bringing to them, right? That's for if you're the product manager of an API product. And if you're on the other side of it, if you're trying to integrate with an API, you should be able to understand what that API is doing for your team. You need to be able to understand the business value that it's bringing. So good documentation is also very, very important. Something you all have also mentioned in passing, but I will just touch on again, is that API should also have consistent structure, because at the end of the day, APIs have a standard and they should also be able to handle errors correctly. They should be able to work as they are supposed to. So that's what makes good or bad APIs. So we've touched on this a little, but I wanted to speak more on it. While it's important to know the technical parts, HTTP, all of that, it's also very important to think about what this all means to us as product managers. What are the important things I need to think about when trying to select an API or even build one with my team? Can anyone take a stab at this? I feel like, what? Can you hear me?
Yeah, I was trying to read another question that came in. I don't know if that's what you were talking about just now.
Oh, okay.
From Victor.
Okay.
Yeah, so the question came in and he's asking, can we integrate two APIs that does the same thing in case one is down? So sort of like have a backup API. That's what he's asking.
You know what? I've been seeing a lot of people do that, but while yes, you can, I would also say you should think about it very well, because a lot of these APIs come with their own different user experience, right? So you don't want that users are having different experiences and things just feel very wishy-washy for your users. So while you can do that, take Google Maps and whatever kind of map API is available out there, right? Maybe Waze. So you integrate with Google Maps and you integrate with Waze. The way they would look to your users would be very, very different. So you need to think about that. You need to think about the trade-offs of that. If your users would be glad, because of course some people prefer using this over this, right? But then you need to think about that user experience, and also while the user experience is great, you also need to think about like, is it doing what it's supposed to do? So I think it's not a question of can you, is the question of should you, right? Think of how your users would feel at the end of the day, because they're your main customers. So you can, but should you? Okay, I think I can see hands up.
So yeah, hi.
Yeah, okay.
I just want to like
touch on that.
Okay.
Two APIs are connected to, and this is how it is being built, right? They're like like I don't know how it is being built basically, but they like have a way that when you call, right, they decide where it's going at that moment, right? So that when one is down, they can quickly say go to this other one, right? Like it is not it's in a case of payments. I mean like maybe you integrate with Paystack and Flutterwave at the same time, right? When Flutterwave is down, they just quickly do like a small settings, and before you know it, automatically their customers can use Flutterwave immediately, kind of thing.
Mm-hmm. Well, to be honest, I think yes, you definitely can. Something that also just came to mind for me is partnership APIs. A lot of them have to sign agreements. So within those agreements, I think the things that I would just put out there for you to think about is you definitely can. You can have a fail safe and things like that, but you need to think about, the agreement that you have. If it's a partnership agreement with the other company, make sure you read the lines. You don't want to be against it, or you don't want to be a fugitive, or you want to go against the law or whatever contract you have. You also need to think about the user experience. So you definitely can, because like I'm not sure who spoke just now, but the Paystack and Flutterwave one, imagine I'm really trying to get this product and I don't even really care about how I'm paying. I just want to pay and be able to order this thing. So that's something you need to think about. You need to think about what is actually really important to your users, right? If the whole, this looks different, I'm annoyed by that, is more important to your users than actually getting things done. So that's also something you can think about. Someone, I can see a lot of hands up.
Yeah. So I
was trying to ask.
Okay. Okay, maybe we can just get this one and then we'll continue. There'll be a Q&A session at the end of it, so we can converse and exchange ideas at the end of it all. Right? Does anyone want to speak now, or should I just continue? One person can speak now, and then
just quickly, just quickly to what you said. The Paystack Flutterwave, especially if it is a partnership API, not even a integration to build a product. I think it's not just easy to do a follover switching between Paystack and Flutterwave, because there's a cost incurred. And like I think somebody made mention of a solution. I've never tried it before. I don't fully understand what is. But he said something about hosting on a cloud, applying redundancy configurations for 100% availability. But a suggestion I would think of is if it is an integration for identity verification, yes, maybe the cost would not be so high. But if it's a case of payments, instead of switching between Paystack and Flutterwave, you can probably switch between Paystack and another payment option. For instance, maybe a transfer as compared to Paystack, or even a card transaction, like a POS card transaction, in my opinion.
Yeah, that sounds honestly reasonable, because one of the things that I've mentioned is, the costs of these things. So as I've said, you can, You can, but those things you need to think about those things. They need to make sense at the end of the day. You can do whatever you like, but are you going against the partnership? Is this cost something that your company is willing to bear, and also the user experience of it all? So okay, at the end of this, we can have conversations, back and forth and exchange ideas. So we're almost through, honestly. So let me just wrap up and then we can continue the conversation. Right?
Yeah, to be
Awesome.
one
So
more just before you continue. Hi, Tobi.
What?
Yeah, one more
Okay,
just
hi.
before you continue. Yeah, so there's one more
Okay.
question that came in the chat, and Chimerie is asking, what would cause an API to be down? I think after that we can just continue.
You know what? Anything. It can be a little maybe they were trying to upgrade something. One push would just break everything. Different things. It can also be network, right? Several things can cause, well, in the case of network, the API won't be down. It's just you that won't be able to access it. But there are several things that could cause APIs to be down. But I think the most, or in my opinion, when I've been working, what really causes APIs to be down is, a change. Because in fact, I think I will touch on it a little further down. But when something changes on the API you're integrated with, or something changes, you need to change as well. You need to change things. So when they change things and maybe the communication wasn't just as smooth and you've not been able to change it, your users won't be able to use that API at that point in time, and things like that. So there are several reasons, but I think one of the main reasons is a change in the API. And improper testing. Oh my God, it's it can be anything. It can be, the API can just wake up and even decide. I'm joking, but it can be anything. It can be a lot of things. Okay, let me just continue. So the things, or what are the important things that we need to consider as APIs, or as PMs rather, when selecting APIs. Some of the points I have here are, for one, the relevance to the business. We've spoken about this shortly, but I can't be working on a fintech enterprise solution now and be thinking of how to add Google Maps to that enterprise solution. It doesn't make sense. I did say, dream big. Wherever you stop is where the API stops or whatever, but it has to make sense at the end of the day. Then we have information security, right? Data leaks are very, very messy, and it's a complete no in this landscape. We need to consider the information we'll be sending through the API, the information we'll be getting back, and how secure the whole thing is. Imagine if, as I've even said this, imagine if on an e-commerce website, someone were able to hack and get customer details or BVNs. That would be very, very messy. You and your company on the streets of Twitter, and then the loss in revenue would be honestly devastating too. Then we have intellectual property. You need to consider how to protect the company's intellectual property, and also how to not infringe on any agreements to prevent intellectual property theft, right? We also have issues with third-party APIs, and in fact, I just mentioned this. If something changes on the API, on the third-party APIs side of things, you have to make those changes on your own end to ensure that your user experience isn't interrupted. So you have to keep abreast of those things. You have to make sure that you are in constant, you're in the know of those things, right? And also, like, imagine if the company that you even integrated with for your payments, for instance, goes belly up. What will happen to the API? What will happen to your product? What will happen to the product that is dependent on that API? You have to think about all these things. Well, we can't really see the future or know which company is going to go down in the next few days or months. We need to be careful. We need to be prudent. We need to think about these things deeply, and also know how this might affect the product and the customers. And then we briefly touched on the next 2 points in the pros and cons of APIs. We think about the stability and performance of the APIs. How often does it go offline? Not that the customer is trying to buy something on my website and the portal is not working, the payment portal is offline. You need to be able to know these things, properly document, and try to be on top of things. Okay. And so how can we use APIs to the full capacity? How can we just use APIs and harness the powers of APIs? I've said this a lot and I can't say it enough. APIs open up a world of new products, new ideas, new business opportunities. And to get the full benefits, we typically use APIs in 3 ways. We've spoken about how you can either integrate the third-party API, you can build your own API for internal use, and then you can build and expose your own API to your customers, kind of like how Paystack does it, right? And there are a lot of mixes of these options and opportunities. And to fully get to understand, to be able to get a wide view of these opportunities and to get like a holistic view of these things, I'd say, you need to read up, you need to be up to date, you need to, Medium, Google, API documentation. There are several resources to help you, stay on top of things. Don't be scared of technical things. It's nobody knows everything, as I've said. Ask questions, find your ally in the engineering team, find someone that if you're getting lost, you can quickly be like, oh, please, what does this thing mean? Or what does that thing mean? You can always Google, check, and ask questions when things seem a little scattered. It's not a sin to not know. There are several things that nobody knows everything. We are all just learning. We are all just trying to do our best, right? So you can ask questions and all of that, because at the end of the day, when you know those things, when you find your way into those things and fully get into the powers of APIs or the things that can be done with those APIs, you'll be able to find solutions, beautiful and pretty easy solutions, to be honest, to the problems that a lot of your customers are facing. You'll be able to get even solutions to problems that they are not yet facing, but that they will face, and you'll be able to stay on top of things and mesmerize your customers. And something that is also very important to know and to just take is that you can't build everything. You shouldn't even try to build everything. There are several APIs that do several things. And so you should be able to balance my team can do this, my team can build this with, there's probably an API that can help us with this, and we should, research into it and all of that. It's also important for engineers to know that, because I think engineers are also very stubborn. They want to build everything. They want to just do everything. I'm part of them. And I'd also like to add, especially for PMs that started out as software engineers, don't get hung up on the how. Don't get hung up on the technologies or the things that are supposed to build those products. Focus on the why, focus on the customers, focus on why you're building these things. Don't try to bother yourself with how the solution is being built. It's nice to know, but don't bother yourself too much with that. It won't help you, it won't help the engineers, and it won't help the customers to just focus on the why. And so a little recap for the second half of this workshop. We talked at length about the types of APIs, by availability, private, public, partnership APIs, use cases, and then we went on to talk about the pros and cons of APIs, how while it can help you save time, it might also cost money. We also want to be able to balance all of that. We also went into what makes a good API, great documentation, little to no downtime, security, and so on. And then we spoke about the things to consider when building or integrating with APIs, business goals, intellectual property. And finally, we briefly discussed how we can harness the power of APIs, the importance of reading and being up to date as a PM, and not being scared of technical concepts. So there's just references, and there's a little game to help us just go over a few of the concepts. It's just a fun game. Kindly join on the website with the code on your screen. It shouldn't take more than 5 minutes. It's just a fun thing that I like to do at the end of workshops or like conversations like this. Let me share that part of my screen. So you can also use this QR code. Okay, I think we should start. Okay. So one of the buckets for types of APIs. I hope you guys were following me. Yeah, so it's by use cases, right? You know, we spoke about APIs by availability, and we spoke about APIs by use cases. Availability was where we spoke about private, partnership, and public, and then by use cases, we spoke about database, OS, web, remote, and web APIs. So okay, let's go on. Let's see the leaderboard. All right. Abo is going is number one at this point. Okay, let's go. True or false? It's very interesting to see. Okay, so most of us are still following. So of course, HTTP is not more secure than HTTPS, so it's false. It's even literally in the name HTTPS. S is for secure, and it's HTTPS has the secure connection while HTTP doesn't. Okay. So we still have Abo in number one. Okay. The put method modifies the object. Just think back to my example about my sisters, the post, put, and patch example I gave. I'm not going to give you expo again. All right. Well, the answer is false because okay, let's I think because a lot more people didn't really get this one. Let's get back into it. Okay, so put replaces the object and patch modifies. Put replaces. Remember, I had said with my sister, I asked her to help me get juice. So that was the post, right? And I was like, oh, I want water, right? So I replaced the whole object. I replaced all the parts of that object, and you know that's the put method. So a patch was now me saying, oh, put lemon in it. That's a modification of the object. And I think my confusion or your confusion probably stems from like the English of it. English is very, very funny in a lot of technical things and engineering things, right? While put, if you want to think about it, modification is just changing something, and essentially that was a modification in English terms, but in tech or in technical speak, that was replacing the whole object. So that I think that's where the confusion might have stemmed from. All right, let me go back to, why is this? All right. Let's go back to this page. All right, and love is is now at the top. Okay, so which of these is not important when considering APIs for your product? All right, so none of the above, because you need to think about all of these things. Cost, you know, we had spoken about how some of these APIs bill per request, or bill per request, right? And then intellectual property, we think about that as well. Business goals, I gave the example of me building a financial enterprise solution and then wanting to add Google Maps. It doesn't make business sense. It doesn't make sense at all, right? So you need to think about all of that. So none of the above is actually the answer, right? Okay, and then for the final question, for what we came here to do, what is the full meaning of API? If anybody feels, if anybody feels this one, I've failed. Thank you. Yes, application programming interface. We talk about how, the APIs are just like UI. You tell the machine what to do and the machine returns it to you. So that's UI, right? But APIs work machine to machine. So the client tells the whatever program what to do. So APIs help in that communication. So who is our top person? Love, congratulations. Okay, so I think we can go into the conversation part of things where we can all just share our opinions and speak about different things. All right. I think we are even past time, but I will share all the slides. I'll share everything I promised to share, and you can connect with me and discuss and all of that. I think I'm pretty fun, so thank you. All right, thank you guys, and I hope you enjoyed this workshop as much as I have. I guess have a nice Saturday. Thank you.